Good morning, ladies and gentlemen. I'm Mitchell Goldie. This is Danny Nguyen and Owen Schneider, and we are Team IGT, here to present to you our capstone project, the Headless Terminal. Lottery terminals worldwide are made with touchscreen interfaces that the user or retailer uses to interface with the terminal to produce wagers and to perform other functions necessary for its operation. The motivation for our project was essentially to explore the feasibility of making a headless terminal, one that eschews the touchscreen interface in favor of being entirely voice-driven. The advantages of making such a terminal are as follows. First off, touchscreen interface hardware is expensive and often very fragile. A single resistive or capacitive touchscreen can cost as much as $200. So not having to use one can save IGT a lot of money, and they can make more profit per unit that they produce. Additionally, such a terminal would better serve the needs of IGT's visually impaired customer base. Currently, IGT uses terminals that have a screen that works in conjunction with simple text-to-speech acts that can help visually impaired customers navigate the screen, but our solution would be more robust and more in keeping with the current state of voice technology in the world today. Our best anticipated outcome for this project was basically a fully functional prototype of our terminal. And we are happy to say that we have achieved this best anticipated outcome. We have a fully functional prototype that can implement a full use case, produce wagers, and can interact with the user in a clear and effective way. In order to get to this best anticipated outcome, there were a few important key accomplishments that we had to get. The first one was designing the actual functionality of the terminal. We started out by specifying a general plan for design in our high-level design document at the beginning of last semester. We then specified flows of interaction that we wanted to be able to create between the user and the terminal, which we specified in activity diagrams. We then codified these activity diagrams in a way that was more palatable to IGT in what we called our use case.
The speech-to-text software we decided to use is called Pocket Sphinx. It is open source and available for use in an offline setting, which was one of the constraints for our project. Out of the box, the recognizer was extremely inaccurate, but there were multiple training options we utilized in order to improve this. These things included the acoustic model, the language model, as well as dictionary adjustments that overall improved the performance of our recognizer. The main functionality of our lottery terminal was to produce lottery wagers. A lottery board consists of 6 digits, and multiple boards can be placed on the same ticket. These numbers can also be used for multiple drawings per the user's request. Our lottery terminal is able to place quick pick wagers, which consist of 6 random digits, or manual pick wagers, which the user gives the digits manually. This is great for those users who want to have that option, but the process of doing so is much more cumbersome. Our terminal is also able to adapt to the voice of a user. If there's a specific number or phrase that the terminal is unable to process correctly, the user can enter a training mode. Here, the terminal will ask the user to repeat that specific number or phrase, record it, and will play it back to authenticate clearness. From this, it will adapt its acoustic model and will be better able to understand how a specific sound should be. Since multiple users will have access to the same terminal, it is necessary that the user must log in. This is because of the training done by the acoustic model trainer, and this is to separate the training done between each user. To access the terminal functions, the user must log in, and this is done by giving a 4-digit PIN. If the user does not have an account, they can request to create one. Here, the terminal will ask the user to do some initial training with the terminal, and then they will be able to create their own 4-digit PIN.
One of our key hardware technical accomplishments that we completed for this semester was creating an LED indicator system. The LED indicator system was an extremely important part of our project because it allowed for another way of transferring information from the terminal to the user. We implemented 2 different types of animations using 2 programmable LED strips. The 2 different types of animations are the basic light animation and a dynamic visualization animation. The basic light animation is used to indicate to the user when the correct time is to answer the terminal's questions or requests. The dynamic audio visualization is used to give the appearance that the terminal is talking and allowing the user to see exactly what the terminal is saying. The dynamic audio visualization was created by taking the audio out of a Raspberry Pi and feeding it back into our visualization code. The visualization code then divides the audio signal into 24 distinct frequency bands using a fast Fourier transform, and then we apply different RGB variables that can be dynamically changed, giving the appearance that the terminal is talking. Our final key accomplishment for this semester was creating an enclosure design. The enclosure design was shown here. We chose to use a sphere not only for an aesthetic look, but also because a sphere gives us the largest amount of internal volume, given the smallest amount of external surface area. There's 2 openings cut into the terminal. Oh my God. Here, the top hole for microphone and the bottom hole for a speaker for audio in and out. And then the LED strips are embedded around the circumference of the sphere to show a clear representation of the animations. After the enclosure was completed in the design, we uploaded it into a CAD program, and then we're able to 3D print the design, completing our headless terminal. With that being said, I would like to proudly introduce you to Otto.
Hi, I'm Otto.
Hey, Otto.
How can I help you?
Log in.
Please enter your 4-digit PIN.
1, 2, 3, 4.
Now we use the yellow LED lights to indicate that Danny's specific language model is being uploaded, and it takes a few seconds for it to be uploaded to the system.
You have been logged in.
Hey, Otto.
How can I help you?
Quick pick.
So that will be a quick pick, single board, single draw. Is that correct?
Yes.
Okay, printing ticket.
With that being said, we would like to thank everyone who has made this project possible. Thank you.